for example number 3, it's kind of a roundabout approach of getting into lower and upper estimates for areas underneath the function. So what we're going to do is I'm going to graph out f of x. I'm going to put g of x and h of x on the same graph. And I'm going to go from the interval 0 to 2. So watch. This guy right here. Okay. We'll graph f. I'll just do that in white. Okay. So it's up at a height of 1, at 1 over, and 2 over. At 1 over, okay, so at 0 it's at a height of 1. And let's do it in an actual color here. No, I don't want to. Okay, I changed my mind. So this is a height of 1. Okay, so we know we start out there because if we plug in 0 into this function, we get out 1. If we plug in 1 into this function, I get out 2. So here's 2, 3, 4, 5. So at 1, I'm at a height of 2, and at 2, I'm up here at a height of 5. So my function looks exactly like this. No arrows on the end, no nothing like that, because I'm only on this interval. It's exactly what my function looks like. That's function f, okay? Now let's take a look at function g. Well, g, from 0 to 1, including 0 and including 1, it takes on a height value of 0. So it looks like this. And then at 1, just a little bit past 1, it takes on a height value of 2. So put an open circle here. It takes on a value of 2 over to here, just like that. So now that we have this function here, what we're going to do is we're going to take a look at the area underneath the curve. Well, what we have is it's delta x1 is equal to 1, and its delta x2 is equal to 1. They're both length 1. Now, to find its area, the area of the green, that's equal to the sum when I starts out at 1 and only goes to 2 now, of delta xi times the height of the function. So I'm just going to say g. Well, I really got to be careful with writing that. I'll use k here for the height of the function, so ki. So the first one is going to be k1 delta x1 plus k2 delta x2, like that. So k1 is 0, delta x1 is 1, k2 is 2, delta x2 is 1, so this gives me a value of 2. So it tells me, if I take the area of each of these, okay, my total area estimate is 2. Now that is all underneath the curve f, so we call this a lower estimate of 2 square units, right? I mean, it's lower. We're trying to, big picture, we're trying to find the area underneath this curve. So we're going to estimate it using little rectangles. Well, we use 2 rectangles under here for a lower estimate. And you might say, well, it would have been better to go maybe at a height here, and you're right, it would have. Okay, but that's not the way this function was defined. So now let's take a look at h. Let's do h in blue. Okay, so h, okay, it goes from 0, I'm going to erase this down here, guys. H goes from 0 to 2/3, so right here. That's the first interval. Okay, so on this interval, it takes on a height value of 2. So right here, I'm going to put a closed circle. Here, I'm going to put a closed circle. Okay, just like that. Then from 2/3 to 4/3, which is 1.3 repeating, okay, It's at a height of 4. So let's go up here at a height of 4. Put our circle. We'll close this guy. We'll open this guy just like this. I'm at an angle, I know, so it doesn't look perfectly straight, but you get the idea. And now at 2, I'm up at a height of 5. Okay, so this is a closed circle. This is an open circle. Oops, that just like this. Now if I take each of these areas in blue and I add up all of that area in blue, that gives me an overestimate for the area under F. So let's go ahead and calculate that. Its area, the area in blue, is equal to the sum. Now my indices, I'm going to start at 1, but I've got 3 of these guys, so I'm going to go up to 3, of each of the delta xi's times the heights that they are, which we're calling ki. Now notice that these k's are different than these k's. I could have called them something else, like h's or g's or whatever, it doesn't matter. Okay, it's irrelevant, it's just a variable name. So the first one is, so I have to calculate k1 times delta x1 plus k2 times delta x2 plus k3 times delta x3. So k1, the height of it is 2. Its total length down here, this length right here is delta x1, this length right here is delta x2, and this length right here is delta x3. So delta x1 is 2/3 minus 0, or 2/3. K2 is at a height of 4, so 4 times. Now this length right here is 4/3 minus 2/3, which is 2/3. And then K3 is at a height of 5. Okay. And its length is 6/3 minus 4/3, which is also another 2/3, like that. Okay. So now we'll do this computation here, and when we do this all out, we should get 22/3, which is 7.3 repeating. So that's square units, again, because it's an area. And this is an overestimate for the area underneath the curve F. The true area underneath the curve F is given here in orange. Notice the green is an underestimate for that area in orange, and the blue is an overestimate for the area in orange.